70 million years ago, the mightiest dinosaur that ever lived roamed the Earth. Its name was Tyrannosaurus Rex. It was 13 meters long and weighed 6 tons. This awesomely powerful creature was king of the dinosaurs. Much about T-Rex has been shrouded in mystery. Now, with modern technology, a clear picture is taking shape. Remarkable physical capabilities that defy conventional wisdom. An advanced brain and intellect for hunting.
We look at their brain and wonder whether that enlarged cerebrum may have actually had the capacity to be involved in sort of a coordinated group hunting effort.
In addition, new fossil finds from around the world are revealing the origins of this enormous predator. It turns out that T-Rex's ancestors were actually small and frail.
Well, they weren't, the big bears or the big lions or the big tigers at the top of the food chain. They were something much smaller, much weaker.
Somehow, tyrannosaurs transformed from small creatures threatened by their enemies into the most powerful dinosaurs of them all. Starting with the very earliest ancestors, we'll explore an amazing tale of evolution. Siblings on a journey in search of new lands. They cross paths with a fearsome carnivore. Which will reign supreme? The King of Kings, Tyrannosaurus Rex. This is a story of 100 million years of remarkable evolution. The first Tyrannosaurus fossils were discovered in the United States in the early 20th century. The dinosaur's monstrous appearance inspired its name, Tyrannosaurus Rex, Tyrant Lizard King, or T-Rex for short. For more than a century, scientists have been working to piece together T-Rex's evolution. Stephen Brussati is one of the top researchers in the field.
So everybody in the world has heard of T-Rex, but for a long time there have been some big mysteries about where T-Rex came from, how it evolved, how it got so big. And these have been mysteries for many decades. But finally, over the last 15 years, people all over the world have been finding older, smaller, more primitive tyrannosaurs that tell us where the big ones came from.
Scientists are zeroing in on T-Rex's roots. They've determined that its earliest ancestors first emerged far from North America. This is the Jiangao Basin in the Xinjiang Uyghur Autonomous Region of China. Now dry, this landscape was once home to many different types of dinosaurs. In recent years, excavations have unearthed a wide variety of fossils. Xu Xing has led some of these digs.
一上午其实人已经很疲惫了，但是呢没有找到特别好的东西。你想一天在这个8个小时、10个小时，在这个30、40度的高温下，没有阴凉，这个对人的体力消耗是非常大的。 走着走着，我有一个野外队员叫做于涛，远远的你当然距离比较远，他就是在喊我，我可以听到他喊我，显然很兴奋。我就知道他肯定有什么很重要的发现，在一个小山坡的小冲沟上，所以从牙齿上看，我们就判断可能是一种新的物种。所以，在一个小冲沟的边上，我们就看到了一排黑色的牙齿。当时一看就是典型的吃肉的这个肉食龙的牙齿，当时非常非常兴奋。
Inside a 160 million-year-old soil strata, they found a completely new meat-eating dinosaur. A crown-like appendage on its head inspired its name, Guanlong, or crown lizard. Xu and his team conducted a detailed analysis of the teeth and bones. They determined that Guanlong was T-Rex's ancestor.
我们才意识到我们可能有了这个暴龙家族的最早的代表。当时是非常非常兴奋，应该说。
There they are, a group of Guanlong siblings. They're on the hunt. One takes off. Perhaps he's the oldest. He closes in on his prey. But he's no match. At this point in time, the Guanlong was just 3 meters, dwarfed by the 13-meter-long T-Rex. It weighed only 75 kilograms, 1/80th of the weight of its massive cousin.
The very oldest tyrannosaurs were much, much different, much smaller, but they didn't have anywhere near the firepower of a T-Rex. They were kind of like, cats or dogs, kind of that type of animal. They weren't, the big bears or the big lions or the big tigers at the top of the food chain.
How did such a small and relatively weak creature eventually lead to T-Rex, the largest dinosaur of them all?
The story of Tyrannosaurs is really a story about evolution. And one of the things that it tells us is that evolution is unpredictable. When those very first Tyrannosaurs like Guanlong entered the scene 170 million years ago, you never would have thought that they would ultimately evolve into giant, monstrous animals like T-Rex, but that's what happened. How were they able to survive for so long, for 80 million years, as these small, human-sized carnivores? And then maybe the biggest mystery of all, how were those small tyrannosaurs able to switch and become these giant, dominant super predators?
The keys to unlocking these mysteries are newly discovered fossils from around the world. Researchers have discovered 28 species related to T-Rex. Brusati has conducted detailed analyses of the bones of some of these specimens. His goal was to clarify the process behind T-Rex's evolution. The approach he used is called phylogenetic analysis.
We have hundreds and hundreds of those features that vary in these dinosaurs. Some have the bones, some don't. Some have small muscle attachments, some have big ones. Some have triangle-shaped bones or projections, others have square-shaped ones. Those kind of features that are variable.
Brusati's analyses have illuminated 366 distinctive characteristics of tyrannosaur bones. And the data he's amassed form the basis for mapping T-Rex's family tree. The results confirm that the diminutive Guanlong was indeed the most primitive species of tyrannosaur. From the time the first Guanlong emerged until T-Rex appeared took 100 million years. Over this time, dramatic evolutionary advances created a creature of unparalleled dominance.
So it is an unusual animal, a freak of nature, a feat of evolution. And I'm fascinated to learn, to try to understand how evolution makes
an animal like T-Rex. That's the mystery that drives me in the research that I do.
160 million years ago, China's Junggar Basin was home to the Guanlong. This species then migrated to North America, and about 70 million years ago, T-Rex appeared. The question is why T-Rex's ancestors left their familiar environment and set out on their epic journey. A clue can be found in the southern reaches of the Pacific Ocean. 5,000 meters beneath the surface lies an enormous lava plateau. Naohiko Okochi has studied the formation.
そのサイズがですね、とてつもなく大きくて、北海道から沖縄までがすっぽり入ってしまうほどの大きさですね。だいたい 2000km 四方と。
This huge lava mass was created by a major geological event 120 million years ago. Deep inside the Earth is a swirling mass of matter called the mantle. Magma suddenly surged up, erupting through fissures in the ocean floor. The Pacific Ocean wasn't the only place this occurred. All over the world, volcanoes violently burst to life. These major eruptions also occurred on the Eurasian continent, where the primitive Tyrannosaurs lived. They had no choice but to flee. Leaving familiar territory behind, they began a journey into the unknown. They headed toward the north for a reason. Climate change. The gases released by volcanic eruptions contained large amounts of carbon dioxide. This triggered global warming.
二酸化炭素の濃度が現在の、およそ 2.5 倍から5倍。それによって温室効果が起きまして、植生をですね大きく、北極圏へまで広げ、そしてそれが最終的には恐竜のですね、生態を変えて、あるいは進化を引き起こしたというふうに考えても不思議ではないと思います。
As the Earth warmed, lush forests sprouted up from Siberia to the Arctic. Xu Xing believes this greening of the north encouraged the Tyrannosaur's migration.
从早期的角龙到晚期的这个角龙，总是暴龙家族呢，它是这个猎食性动物，就是吃肉的动物。那么呢，它有时候迁移呢，有时候会随着这个植食性的动物来走，是吧？如果植性动物从这儿迁到那儿，那么这个肉食性动物也会跟着迁。
Triceratops fossils have been found from Eurasia to North America, and they're often found together with fossils of tyrannosaurs. As the forests spread further north, the plant-eating dinosaurs' range expanded. Scientists believe this is what prompted T-Rex's ancestors to begin their migration. Into the unknown. Searching for a new home with bountiful game, they start out on their epic journey. They arrive on the eastern edge of the Eurasian continent. In front of them is a vast ocean. And just when it seems they can't go any further, something incredible happens. Tectonic shifts bring the Eurasian and American continents closer together. Then, a land bridge appears, closing the gap between them. A path has opened. The two siblings make their way toward it and head to a new land. The pair arrives in North America. It's a vast expanse of land covered in lush forests. But it turns out large meat-eating dinosaurs also live here. Before T-Rex, other carnivorous dinosaurs ruled the Americas. Scientists have found fossil remains in the deserts of Utah. Lindsay Zano is a paleontologist who has explored the area. She had been excavating for 5 years. Then, in 2013, she made a significant discovery.
And I was coming around the corner on a low hill and spotted some bone sticking out of the side of the hill. So I got down and looked at the bone and could tell instantly that it was a theropod bone, a very large theropod by the looks of it, and we got very, very excited right away that we'd found a very large species that had never been seen before.
Now the real work began. Team member Peter Makovicki took the fossil to Chicago for further study. His specialty is analyzing dinosaur bones.
The bones we have here are parts of the skeleton of a large carnivorous dinosaur. Even though it's big and superficially might look like Tyrannosaurus, it actually belongs to a very different lineage of meat-eating dinosaurs.
The size of the bones suggested the dinosaur measured about 11 meters from head to tail. It's a relative of Allosaurus from the Jurassic era and is known as Siach. Experts believe this dinosaur had razor-sharp claws and teeth like knives. Such features point to a mega predator.
The name Siach actually comes from the Ute Indian language. It refers to sort of a cannibalistic clown monster, sort of a dangerous creature in their legends, and it is by far the biggest theropod and would likely have been the top predator in its ecosystem.
Close to the Siach fossil find, Zano has recently discovered a relative of Tyrannosaurus.
This is a tooth from one of the mysterious small tyrannosaurs we find here in these rocks that are about 98 million years old. We find the tantalizing remains of tiny little tyrannosaurs, about the size maybe of a small horse.
A tooth from this dinosaur is just about 1/10 the size of that of a T-Rex.
So the tyrannosaurs living here were quite small. They were living in the shadow of dinosaurs like Siach.
The weak Tyrannosaur siblings were now living side by side with this formidable beast. They were absolutely outrivaled in size and in power.
Well, I think, if the small tyrannosaurs that were alive at this time would have run into Siach, it would have been sort of like a fox meeting a lion or a tiger. There's no doubt that there was a very vast difference in body size. So basically what we have is evidence that tyrannosaurs were present at the time, but would have occupied a much lower trophic level among the carnivores than Seats.
Siach stood atop the ecosystem. It was a dangerous environment for the much weaker tyrannosaurs, but somehow they managed to survive. To find out more, Brusati has done research all over the world. In 2016, he came across one fossil that provided some clear answers. It was found in Uzbekistan in Central Asia. An analysis revealed it was from the skull of a new species of tyrannosaur. It's called Timolengia and measured 3 meters long. At a glance, it doesn't seem too different from its smaller ancestors. But internally, it's dramatically different.
We're able to look into its brain, into the ear using CAT scans, and we can see it had a big brain, very intelligent animal. We can see it had an ear that was really sophisticated, really good at hearing a wide range of sounds.
Brusati and his colleagues took scans of the cranium. Inside the inner ear is the cochlear duct, which is responsible for picking up faint sounds. They found that in Timolengia, it had significantly evolved.
So what this is telling us is that these small tyrannosaurs were evolving bigger brains, greater intelligence, better senses, when they were living in the shadows, when they were trying to survive in a world dominated by the allosaurs and other big predators.
Early small tyrannosaurs developed a keen sense of hearing. That allowed them to quickly sense enemies and escape, helping them to survive. But fleeing wouldn't have been enough to challenge and overtake Siach's dominant position. There's more to the mystery of how descendants of these diminutive siblings would have gone on to rule the dinosaur world. For many years, the evolutionary path from Guanlong to the giant T-Rex contained puzzling holes.
So we know a lot about the very earliest tyrannosaurs now. We know they were small. We know a lot about the latest tyrannosaurs. We know they were huge. But in the middle, there's a gap in the fossil record, a dark period of tyrannosaur history where we know nothing. No fossils.
The Tyrannosaur's 100 million year evolutionary history contains an intriguing hole. It was during this time that the spectacular advances that led to T-Rex occurred. Mark Lowen has been researching this mystery. He's focused in on an ancient landmass on the North American continent called Laramidia.
The real changing point of Tyrannosaur evolution was the isolation and evolution that happened on Laramidia. Isolated populations of dinosaurs could evolve in isolation from other dinosaurs.
Around 90 million years ago, global warming caused sea levels to rise. This led to monumental flooding on the North American continent, causing it to become divided. The dinosaurs lived in the western part of the continent. Much of the land was covered with steep mountain ranges. Rising waters drove the dinosaurs to narrow strips of level land, where they became isolated. In these densely populated areas, meat eaters would have a significantly greater chance of finding prey. Lowen believes this is precisely what sped up the dinosaur's evolution.
This crucible of evolution that is Laramidia, the small populations were able to undergo dramatic change and rapid evolution.
revolutionary advances took place in many different creatures. Ankylosaurs evolved thick, bumpy skin like protective armor. Members of the Ornithomimus family developed the ability to run 60 kilometers per hour to escape predators. Similarly pronounced changes occurred among the Triceratops ancestors, hunted by Tyrannosaurs. They adapted for survival by becoming massively large. This gave them the power to repel attacks. From early ancestors weighing only 100 kilograms, they developed into creatures weighing more than 6 tons. But many uncertainties still remain about T-Rex's predecessors. In 2013, Lowen discovered a fossil that answered some questions. It's from a previously unknown species of tyrannosaur called Lythronax. The fossil was buried in soil deposited 80 million years ago, during the evolutionary gap period.
The name we chose, Lythronax, means Gore King in ancient Greek. And we chose this name because Lythronax really was the top predator in its ecosystem.
The fossil indicates that Lythronax measured about 8 meters in length. That represents a remarkable jump in size from Guanlong, its weak ancestor. This new tyrannosaur was large enough to battle with the massive Triceratops. Conditions were ripe for different species to influence one another's evolution. This phenomenon is known as co-evolution.
So tyrannosaurs were exploiting these prey species and also undergoing rapid evolution themselves. So it's really an arms race between the predators and the prey species, and all of these animals are evolving to have larger body size, both to defend themselves from predators and for the predators to be able to attack the herbivores.
Researchers believe that one factor supporting the tyrannosaur's extraordinary growth was a jump in their hunting skills. Their heads, relatively delicate up to then, widened by about 3 times. That made astonishing improvements in eyesight possible.
One of the things that's unique about Lythronax is the fact that it has forward-facing eyes. Forward-facing eyes occur in modern animals that are predators. And the ability to have forward-facing eyes allows you to have overlapping field of vision and perceive depth. So depth perception clearly was possible in this dinosaur, and it's something we associate with hunting.
Depth perception makes it possible for a hunter to accurately grasp the distance to its prey. That would have allowed tyrannosaurs to catch prey more easily and turned them into much more successful hunters. They would have gotten plenty of nutrition, enabling massive growth. These changes culminated in the mightiest dinosaur of all, T-Rex.
By about 80 million years ago, a whole new world of dinosaurs had dawned. And this was a world that was dominated by the tyrannosaurs. They were the biggest predators and they ruled at the top of the food chain. And these were the tyrannosaurs that we're all familiar with. The ones like T-Rex. The ones that grew so fast that they put on 5 pounds of weight every day during their teenage years. And they were utterly in control. They were the kings of the late Cretaceous.
Overwhelming size wasn't the only result of the tyrannosaur's continuous evolution. Lawrence Whitmer is a paleontologist who has studied the brains of T-Rex. He's used CT scans of fossils to analyze their brain structure. The scans point to new developments in sensory faculties.
One thing we saw when we started to reconstruct the brain of T-Rex is that the olfactory bulbs of the brain, the part of the brain that's involved in processing odors or smells, were really quite enlarged. What that told us is that the sense of smell was very important for T-Rex. It was potentially important for locating its prey.
Signals from the sensory organs were sent to and analyzed by the cerebrum. An index measuring intelligence based on brain to body size suggests T-Rex was more advanced relative to other dinosaurs.
The cerebrum, which in mammals like us is the seat of intelligence and planning and problem solving. The cerebrum in Tyrannosaurus was actually fairly expanded. We look at their brain and wonder whether that enlarged cerebrum may have actually had the capacity to be involved in sort of a coordinated group hunting effort, such that maybe some animals would actually drive the prey towards other animals, other tyrannosaurs that were laying in wait.
There he is, T-Rex. He's not only smarter, but also has a superior sense of smell. Even in the dark of night, he's able to locate his prey. Aiding his ability to track game is his keen eyesight. The Triceratops tries desperately to get away. But there's another T-Rex waiting in an ambush. Feasting on kills fueled growth. The Tyrannosaurs now measured 13 meters. Their bones grew harder and stronger, and their bodies were covered in muscles like steel. Some experts have questioned whether creatures this big had the speed needed to run down prey. The conventional belief was that T-Rex ran at a speed of 18 kilometers per hour. That would make it slower than a human. Tyrannosaurs were thought of as slow and clumsy. Paleontologist Bill Sellers challenged that view.
So it's very hard when all you've got is bones to try and work out how fast an animal would run. So what we were trying to do was to come up with evidence from living animals that we could use to work out how fast fossil animals would move.
Sellers and his colleagues looked for present-day animals that would approximate the movements of a tyrannosaur. They zeroed in on the ostrich.
And these ostriches are as close as we can get in terms of a modern animal that's a bit like a T-Rex. So they've got 2 legs, they've got very large bodies, and they're high-speed runners. A lot of the basic anatomy is exactly the same, so they do make a very good model.
Using the ostrich's movement as a reference, Sellers made a computer simulation of how a T-Rex might have run. The model showed which muscles a T-Rex would have used when running. Sellers took particular notice of the muscles connecting the thighs and the tail. Previously, experts thought these muscles were merely for tail movement, but it became clear that they also played a key role in helping the T-Rex to run fast.
And what it does is it pulls the thigh bone backwards. And so obviously this is the main powerhouse. Even though it's a very heavy animal, it can obviously generate the force that it needs to go at a good speed.
With this model, the average T-Rex's top speed increases to 30 kilometers per hour, and the strongest could run as fast as 50. The descendants of the primitive Tyrannosaur siblings have acquired speed, size, and intelligence. But there's more. Carl Bates is an expert on the bite force of dinosaurs.
With an enormous bite force and large neck muscles, it probably clamped onto its prey and pulled away at the flesh. There have been quite a few fossils found of plant-eating dinosaurs with T-Rex bite marks in them, where the bite marks go very deep into the bones.
A huge jaw powered this deadly bite. Bates has studied the structure of T-Rex's skull. He recreated the muscles that connected the upper and lower jaws. Then he used a computer simulation to quantify the strength of its bite. Bite force is measured in newtons. The lion, known as the king of the savannah, has a bite force of 4,000 newtons. The bite force of alligators, fearsome killers near water, is around 6,000 newtons. Compare this to the dinosaurs. The Allosaurus is considered to have been the strongest dinosaur before T-Rex. Its bite force was about 9,000 newtons. According to Bates, the T-Rex had a bite force of some 60,000 newtons. That's 7 times greater than the Allosaurus.
60,000 newtons is a huge amount of force, so we're convinced that T-Rex had a very large bite in absolute terms and was probably one of the fiercest biters of all time.
When a T-Rex bit into its prey, it exerted 6 tons of force. That's equivalent to the weight of an African elephant. In theory, such heavy loads could cause the jawbones to break. But something protected T-Rex from this.
That the skull was very important for capturing prey and consuming prey, and we were just interested in how this huge structure performed mechanically.
A T-Rex skull is made up of more than 40 different parts. Here and there are gaps measuring just a few millimeters. These gaps released force when the T-Rex bit and helped to soften the shock.
T-Rex has this reputation of being such a deadly, fearsome creature, so we're pretty convinced that T-Rex was one of the most ferocious biters of all time and worthy of the title King of the Dinosaurs.
A creature with both extraordinary physical capabilities and sophisticated intelligence. After 100 million years, T-Rex had reached the pinnacle of its evolution. A pair of T-Rex siblings. Even if they were to meet up with Siach, former ruler of the dinosaurs, they would have no reason to flee. They are no longer the small, weak Tyrannosaurs of old. The siblings set off on a new journey, in search of more prey. They are heading back to the Eurasian continent. Along the way, they pass through areas inhabited by many relatives from the Tyrannosaur family.
T-Rex was the king of the late Cretaceous, no doubt about that. But not all tyrannosaurs that lived at that time were big, top-of-the-food chain predators like T-Rex. Some of them actually were quite a bit smaller. So even when T-Rex was ruling the world, there were other close cousins of T-Rex that were doing other things, filling other roles in the ecosystem, and doing a very good job at it.
2014. In northern Alaska, researchers found a new species of Tyrannosaur. They called it Nanooksaurus, after the Inuit word for polar bear. At 6 meters, it wasn't even half the size of T-Rex. Experts attribute its small size to a lack of game. The same year, in Jiangxi province in southern China, a team dug up an unusual fossil. The most noticeable feature is its long, thin nose. It's been nicknamed Pinocchio Rex in reference to the beloved character. Outwardly, it looks nothing like T-Rex, but a bone analysis confirmed it as a new Tyrannosaur species. Then, in July 2015, scientists made a discovery in Japan. Up until then, no one thought large tyrannosaurs had lived there. The team found fossils of 2 large teeth, each measuring 8 centimeters. Their size suggests they came from an animal 10 meters long. Finds like these illustrate the distinctive evolutionary paths taken by tyrannosaurs all over the world. So far, experts have identified 28 individual species. At one point, T-Rex truly dominated the dinosaur world, but in the end, it would meet a cruel fate. Evidence of this emerged in 2015. Scientists were excavating in Alberta province in Western Canada. They found this fossil, a cousin of T-Rex called Daspletosaurus. Here and there, researchers spotted telltale signs of battle. A wound deep enough to pierce the bone. On the back of the skull, a part had been bitten off. Scientists wondered what kind of creature could have inflicted such wounds on the mighty Tyrannosaur. Paleontologist David Hone points to an unlikely suspect.
So you immediately have only one credible candidate for these kinds of injuries and these kinds of bites, and that's another large-bodied tyrannosaur.
Hone says the shape and size of the bite marks indicate a fight between 2 members of the Tyrannosaur family.
They're going to hunt at the same time of day in the same place and have similar territories, and they're going to come into these conflicts. But I'm sure every so often there were fights to the death, and certainly we actually see evidence of cannibalism among tyrannosaurs. They do kill each other.
In turf battles, even siblings could become rivals. And if one refused to back down, T-Rex ancestors set out on a grand journey in search of new lands. On the North American continent, they confronted countless threats. But they managed to thrive. Descendants continued to evolve, eventually becoming the undisputed rulers of the dinosaurs. But once at the top, these powerful killers turned their awesome power on one another. "66 million years ago, the reign of the dinosaurs came to a sudden end. Experts believe the reason was a gigantic asteroid that smashed into Earth. Resulting climate change wiped out the dinosaurs, including Tyrannosaurus. But was that really the end of the dinosaurs? Stephen Brussatti's research provides evidence that it wasn't. Certain creatures alive today are descended from a branch of the Tyrannosaur family. Birds. Once the dinosaurs died out, birds underwent a spectacular evolution. New species appeared, and they became the rulers of the skies. They were able to do this because of strengths they inherited from their Tyrannosaur ancestors.
We always talk about dinosaurs going extinct 66 million years ago when the asteroid hit, but really not all dinosaurs went extinct. Most of them did, but one type of dinosaur survived, and those are the birds. So birds evolved from dinosaurs, and they're actually a type of dinosaur, and they live on today. There's over 10,000 species of birds. There's birds flying around here. And so these birds are living dinosaurs, and so birds today carry on the genes of T-Rex.
Creatures unlike any seen before or since. The free spirit of T-Rex lives on.